Hi, my name is Lars Christensen. In this video, I'm going to show you how to program this test part from start to finish with HSMWorks. So we're going to move from the model environment where we are here to the CAM workspace. Now, if you're already familiar with SOLIDWORKS, you will see that everything is very similar. The menus looks the same and our toolpath will be created in the same fashion as features in our CAD workspace. First thing you always have to do when starting a CAM project is create a job. This is where we define how our model's XYZ is compared out at the machine. See, at the machine it's pretty defined what is up and down, left and right, but in the CAD world there's no rules. You will receive models from engineers and designers where they clearly missed what was up and down on the model. Second thing we will do in the job is to define where we are going to pick up the part out at the machine. This process is pretty easy. First, always just start from the top and work your way down. This is a milling part, so we can move on to the stock section. This is used for simulation, giving us an important picture into the future, letting us know what's going to happen when we hit that green button out at the machine. By default, we have relative stock, what means that the machine has placed a box that surrounds our model and we can add some additional stock. But also be aware that there's a fixed size stock. This is great if you actually have the stock in your hand so you can measure it. Also, I want you to be aware that there is also something called solids. You can actually model up your stock. This is great if you're machining castings and that kind of stuff. I will go back and set it to relative size stock and add 100,000s to the sides and to the top of our part. Next, we will set the work coordinate system. You will see in the drop-down that there's multiple options, but honestly, I only use select Z and X, so just worry about that one. You will see that we get a 3D triad displayed on the screen. This is the one that we need to resemble what we have out at the machine. You will see that there's a selection spot for X and one for Z that right now have my top plane selected. There's two rules when it comes to selecting for our 3D triad. One, if you select a face, the axis will go perpendicular to that face. Number two, if you select an edge, the axis will go along that edge. So with our Z already defined, let's set our X-axis. So if I go over here and I click on this face, you will see the X-axis will jump perpendicular to that face. If I instead go over and select an edge, you will see that the X-axis is going to go along that edge. So two rules: select the face, the axis will go perpendicular, select an edge, and the axis will go along. Trust me, this is the hardest part when it comes to set up CAM for HSMWorks. Click on a face and it will go perpendicular, click on an edge and it will go along. Now when we have our axis all straightened out, let's select where we're going to pick up the part at the machine. This is also what many times will be referred to as G54 or G55. I'm going to click on the top center right beneath stock options. You will see there's a lot of options, and this is really up to you. If you're a die maker, you normally want to select a corner. So if we pick top corner 1, you will see that we get to the lower left corner. If you pick top corner 3, we go to the upper left. If you're a mold maker, you might want to pick the top center. That's where I'm going to leave mine. So I'm standing out of the machine. I tram my part in with an indicator, so I'm in the middle of my part with X and Y. We're going to hit OK, and we're now ready to apply our first toolpaths. Now for this, we'll pick between standard 2-axis and 3-axis toolpath. I will start with a standard facing. This will establish a flat datum on top of our part, and I think generally most CNC programmers will start with this. Now, one thing that is important that I point out is that you will see the menus are going to be the same no matter what toolpath we pick. This goes for turning and also for 5-axis toolpath. The 5 tabs will always be in the same order and have the same meaning. This not only does it easy to learn, but also easy to remember, especially if days or weeks could go by before you get back into the software. The first tab is always where you select your tool. Think of it as the same as if you were out on the shop floor. After you find your material, next thing would be to figure out what tools you have on hand. In the tool library, I'm going to scroll down to the tutorial folder and click on that. Most shops would have some kind of a face mill or big diameter insert cutter. But just to keep the tooling down for this specific job, I will pick a 1/2-inch end mill and click OK. You will see that we can adjust feet and speeds down here, but we will come back to that a little later. Next tab is your geometry tab. You will see that the software have already created an orange boundary box around the part. It is smart enough to know that this is a facing operation, so you probably want to face off the entire stock. Now we will come back to change this boundary later, but for now, let's just hit OK. We just created our first toolpath. And we can at any time go up and click Simulate, and we go down and click the play button, we get a good picture of what is going to happen out of the machine when we press Cycle Start. Now let's jump from a 2D facing operation to a 3D adaptive toolpath. Again, first tab is always where we select our tool, but as you can see, the software remembers that the last tool we picked. Just like before, feet and speeds comes later. Now, many times when I program, I just select my tool and then I click OK and take a look at what the software gives me. This is a lot easier than if you have to go in and change a bunch of settings and then come back and try to figure out what changed what. One thing that stands out is that the tool will machine all the way down to the bottom of the part. I was kind of planning on holding on to this in a vise. So to edit our tool, we will go and right-click on the adaptive operation and select Edit. So the first tab is always the tool. The second tab is where you can select your geometry. The third tab is where you can adjust all your heights. Here I recommend that you start from the bottom and work your way up. Just because when it comes to machining, the depth is always your first concern. You will see that the bottom height is set to model bottom. I'm just going to make an adjustment on the bottom offset. So I was thinking about holding on to the part with a 1/2 inch. And then I'll add another thousandths for safety. As you can see, we can do math right within here. Next tab is the Passes tab. This has everything to do with the cutter engaged in the material. Here are a few things I want you to be aware of. This toolpath, Adaptive, will calculate a constant chip load between our model on the screen and the stock specified. This means that you will never come across a situation where your cutter will dig into a corner and in the worst case break. Because of that, we can go the full depth of our cutter, finally using the whole flute length that you paid for. And we can adjust the load of the cutter here in the optimal load section. This really comes down to what type of machine you got. I was planning on running this part in 6061 aluminum on a Haas VF2. So 200 thousandths load should not be a real problem. But if you want to be conservative, let's change it to 100 thousandths. Just remember, if this value goes into the thousands, you could be rubbing with the cutter. Also notice how we have stock to leave turned on down here, leaving material for a finishing cut. Now let's hit OK. And if you never used adaptive toolpath before, we should simulate it. I will click on the job and thereby selecting both the facing and the adaptive, and this time we will select stock simulate so we also get the stock displayed on the screen. Hit play and notice how you can speed or slow down the pace here. After our facing operation, you will see the adaptive toolpath utilizing a constant load on the cutter, making sure our cutter is going to last a lot longer. You will notice that the adaptive only removes stock where the cutter will fit. The clover pocket at the top was left alone because we need a smaller cutter. For this, let's explore the 2D adaptive toolpath. Again, we're finding ourselves with the task of picking a tool first. This time, I will pick a 1/4" flat end mill out of the tutorial library and hit OK. Feeds and speeds are for later. Second tab is our geometry tab. And I'm going to pick the bottom edge of the clover pocket and click OK. If we zoom in a little, you will see how unified the step over is on the bottom. Also notice how the tool is entering the material using a spiral entry. Here's a cool tip. If we go back into the toolpath by right-clicking and select Edit, then go to the last tab. This one is all about how we enter and leave the cut. In our ramp section, you will see that there is a ramp taper angle. We will change that to 10 and hit OK. And you will see now that the spiral entry has a cone shape. This will put a lot less pressure on the cutter and on the Z-axis. End result, much better way to make chips. Now I want to come back to the facing operation we started with. With all this material removed from the adaptive operations, one could argue that we really only need to create a top datum on a much smaller surface. Check this out. First off, we can drag and drop any operation in the job tree. So instead of having the facing operation first, we can drag it to the end. Second, if we edit the facing and go to our geometry tab, we can redefine the area we really need. Again, let's pick job in the operation tree and select all operation and go to simulation. Notice the colored bar at the bottom of our window. We can click the slider and speed our simulation to any point. So let's fast forward to our new facing operation. Going back to a special 3D toolpath, the horizontal toolpath. Now, many times when we're talking about 3D, we're thinking of surfaces that has a curve to it. But most of the times, there's also flat areas between. That is where this toolpath shines. To keep things simple, and our tools limited, I will select the same 1/4" end mill. Now for geometry, I will hit the drop down and select selections. With 3D toolpaths, we can easily control the boundaries we want our tool to operate within. I am going to select the 2 edges that we want the toolpath to work within. Then also notice how we can change the tool containment within those edges. I will change it to center of tool, but add an additional 100,000 for the offsets. Pretty much telling our tool that we don't want the cutter to go past the center of our boundary, but we will let it start from the outside and work its way in. Again, you will see a nice representation on the toolpath on the part. Now it's time to apply some more finishing toolpath. We will use the 2D pocket toolpath to finish the 2 open pockets at each end and the clover shape on top. Again, we will stick with our 1/4" end mill, and before we select our geometry, we will uncheck Propagate along Z. Select the edges of our open pocket and the clover, and then also turn on Stock Contours. This will make sure that the software is taking our stock into consideration. On the Passes tab, we will check Finishing Passes to make sure that we get a nice cleanup pass. Lastly, because this operation will finish the pockets, we will uncheck Stock to Leave. Hit OK. Now, I noticed that our clover pocket also have a ramp on the finishing pass. We can shave some time of the machining process by going back into the operation, and if you remember, the last tab, the linking tab, here we can adjust our entry to a plunge, and then go back and let's do a stock simulation. Let's apply the last finishes passes to the model. We will use a 3D contour operation to machine the 3D cone surface. For this, we will use a ball end mill. So we'll go into our tutorial folder and find one of those. Just like with the horizontal toolpath, we will choose Selection and pick the two edges for our boundary. I will change our tool to Center Boundary, and I will also select Contact Boundary. That will calculate the tangency between the curved surface on the ball end mill and the surface that we are going to be machining. You can always read more in depth about these functions by resting your mouse over a selection area. Now, with the amount left over from the adaptive, I will prefer to create a semi-finished toolpath. On the Passes tab, I will check Stock to Leave and leave 10 thousandths on both radial and axial stock. For this one, I will leave a 40 thousandths step over. When it comes to deciding on finishing 3-axis toolpath, there's always two factors: required surface finish and time. Time equals money, right? The smaller step over, the better surface. But also, with a smaller step over come longer cycle times. Let's get our feeds and speeds straightened out so we can make a good judgment on the last surfacing machining. We can access all our tools through the tool library on the ribbon bar. We will start with the 1/2-inch end mill. Right-click and select Edit and go to the last tab, Feeds and Speeds. Now, feeds and speeds really depends on what kind of machine and tooling you have on hand. You need to use your best judgment. I will be machining this in either aluminum or soft steel, as it's just a test piece. I'll be using a medium-sized vertical mill, like a Haas VF2. So I will go with a surface speed of 1 thousandths and a chip load of 2 thousandths of an inch. This should be fairly conservative for this type of machine. Next, I will right-click and select Edit for the 1/4-inch flat end mill. This is a little smaller, so I will go with 800 surface feet per minute and only 1 thousandth of an inch chip load. Lastly, our ball end mill. Here I will go with 400 surface feet per minute and 2 thousandths chip load. With all the feeds and speeds updated, we can now check our cycle times. I will click the plus sign next to our semi-finished surface toolpath and right-click the bottom parameter and select Machining Time. We will see we have a strategy that will take right under 5 minutes. This gives me confidence that we can easily adjust our toolpath and ensure good cycle time and acceptable surface finish. Instead of selecting another 3D contour toolpath from the ribbon bar at the top and do all our selections over, I will right-click on our semi-finish and select Derived Operation and navigate to a 3D contour toolpath. This will assure that all our selections and settings are brought right into this toolpath. Now we just need to make a few adjustments. Like go to the Passes tab and uncheck Stock to Leave. And Just to get an idea, let's change the maximum step over to only 1/1000. This will probably cause our machining time to take too long, but the idea that within HSMWorks we can easily get valuable information and then make good decisions. We will let our finishing toolpath calculate and then go and check the machining time. This will take the finishing pass over 2 hours. It will look great, but honestly, I think we need to have this test piece finished within 1 hour. I will go back and adjust the step over to 0.005 of an inch. Let's go back, and if we check the toolpath now, we will see that the machining time is way less than 1 hour. We also need to clean up the perimeter of this part. So we will jump from a 3D contour to a 2D contour. Again, the first tab is always the tool. We will use the same 1/2 inch end mill as before. When it comes to the geometry selection, we will pick the bottom edge of the part. And we can easily raise the tool by going to the Heights tab and use the bottom offset, 600 of an inch, as what we did for the adaptive earlier, and hit OK. This toolpath comes out great, but I want to show you a little trick. See how the end mill enters on the center of the surface. If you have ever seen this in the past, you will know that you get a little lead-in, lead-out mark from the cutter being sucked into the material. Here's an easy fix. Right-click and select Edit. Go to the last linking tab and select Entry Position. Then select the corner edge and hit OK. An easy tip to make your parts look more professional. Last toolpath we're going to apply will make anyone who has to handle a part after it comes out of the mill happy. We will do a little deburring with a chamfer mill. Here, HSM has a pretty powerful toolpath. In the drop-down, you will find the 2D chamfer. To no one's surprise, the first selection is the tool, and we will navigate to the tool library and find the chamfer mill. For our geometry, we will select the top edge around the part, the top edge of our clover, and then, maybe to someone's surprise, we will select the edge of each open pocket. Now, if you have ever tried to deburr parts in a mill, you know that gouging can be a nightmare. But the 2D chamfer here is totally aware of the area of conflict. On the Passes tab, I will adjust the chamfer width to 20 thousandths. On the preview, you will see the toolpath is short, but of course, the best way to verify everything is to simulating. Now, I will speed it up. Check out the chamfer toolpath. See how the cutter comes in and leaves a nice chamfer while still keeping a safe distance to the vertical wall. With this, we only have a few steps left. First, let's make sure that all our tool numbers are in the right order. We will go back into the tool library by clicking on the tool library and right-click in the empty area. Select Renumber Tools, and the default value of 1 is perfect. Accept and OK. Next, let's pack all that up in a setup sheet we can bring out to the CNC machine. Click the setup sheet on the ribbon bar, and the customizable HTML sheet with machining times and valuable information will be ready for print. Last, but maybe most important, the actual code for the machine. Notice all the post-processors that ships with HSMWorks. And just so you know, if you click the post library link, you will find an extensive library of free posts for every major machines on the market. I will select the Haas post and click OK, and our editor will appear with our now ready to be machined code. I hope that you found this video helpful, and I hope that this gave you the courage to go out and test out the code on your CNC mill.